This is the occipital lobe. It's your internal movie screen responsible for vision, and when a seizure strikes, the world can suddenly explode into colors, shapes, or go completely dark. Chapter 1. Location and Appearance. The occipital lobe is the smallest of the four major cerebral lobes, tucked away at the very back of the brain. It lies behind the parietal and temporal lobes, with the parieto-occipital sulcus marking its border in most brain scans. Despite its size, it plays an outsized role in how we understand the visual world. The lobe has a triangular shape, and its most prominent structure is the primary visual cortex, or V1, located around the calcarine fissure. This cortex receives and processes information from the eyes via the optic nerves, thalamus, and optic radiations. From the outside, the occipital lobe appears smooth and compact, but underneath, it's a layered hub of neurons dedicated entirely to decoding light into meaning. Chapter 2. What it does. The occipital lobe is your visual command center. It processes everything you see, from shapes and colors to motion and depth. Visual input first arrives at the primary visual cortex, which breaks down basic features like lines and edges. Then, this data is sent to adjacent visual association areas that interpret it as meaningful images, faces, objects, letters, or landscapes. The dorsal stream sends information to the parietal lobe to help determine where things are in space, while the ventral stream sends information to the temporal lobe to identify what you're looking at. According to Hubel and Wiesel's landmark research in 1962, titled Receptive Fields, Binocular Interaction and Functional Architecture in the Cat's Visual Cortex, specific neurons in the occipital lobe are tuned to detect edges, orientation, and movement. More recently, Grillspector and Malak's 2004 study, The Human Visual Cortex, emphasized how visual recognition relies on the occipital lobe's tight coordination with neighboring brain regions. Chapter 3. What happens during a seizure? Seizures originating in the occipital lobe are often purely visual. Patients might describe flashing lights, color patterns, geometric shapes, or even a sudden blackout in part of their vision. These hallucinations are usually simple and brief, but when the seizure spreads to nearby areas, more complex visual distortions can occur, like faces melting or objects stretching. Some people also experience eye deviation or rapid eye movements during these seizures. In some cases, especially if the seizure is intense or prolonged, a person may lose consciousness, though this usually requires spread beyond the occipital lobe. According to a study by Solano et al., 1992, visual auras are present in more than 80% of occipital seizures and often precede more generalized seizure activity. Another study by Panayotopoulos in 2005 detailed how these seizures can often mimic migraine auras, leading to misdiagnosis in children and adults alike. Chapter 4. What happens when it's damaged? Damage to the occipital lobe can lead to partial or complete vision loss, even when the eyes themselves are healthy. If the primary visual cortex is destroyed in both hemispheres, it can cause cortical blindness. In some cases, individuals lose awareness of their blindness, a condition known as Anton's syndrome. Damage to the visual association areas can result in visual agnosia, where a person can see but cannot recognize objects or faces. This is especially true for lesions in the ventral stream. Chronic occipital seizures can also cause persistent visual disturbances like photophobia or motion sensitivity. Some people develop visual field cuts like hemianopia, where one half of their visual world is missing. Since the occipital lobe is so specialized, damage here doesn't usually affect motor or emotional systems, but it can drastically change a person's ability to interpret and interact with the world around them. And that's it, folks. Thanks for watching, and I'll see you in next Tuesday's episode.